So this next video will be over average rate of change and estimating the values of r equals f theta using the average rate of change. So if we think back to Cartesian, the average rate of change, we have delta y over delta x. It's going to be very similar for polar. Now the relationship between the change in y and change of x are going to be very different, but we're still going to use that difference quotient in order to figure out delta r over delta theta. So if r is equal to f of theta over the interval from a to b, then the average rate of change is going to be, using the interval and using the fact that r is equal to f theta, we're going to have f of b minus f of a divided by b minus a. So if you recall, this is exactly the same setup for delta y over delta x. However, since we are in polar, f of b minus f of a represents the change in the output. The change in the output in polar means the change in the radius from the start of the interval to the end of that interval. And then in the bottom, we have b minus a, which represents the difference with our output. That's going to be delta theta. So I'm not going to use delta y over delta x anymore because I want us to get extremely comfortable with the verbiage that we have in polar. Okay, so it's delta r over delta theta. That's going to be your average rate of change of a polar function over a specific interval. So geometrically, the average rate of change indicates the rate at which the radius is changing per radian. So it's the change in r over the change in theta, which gives us delta r over delta theta. So make another note, because we will be using this later in this lesson. For average rate of change to be 0, that means delta r is equal to 0, which means the difference is equal to 0. So we will be using this in order to find when the average rate of change is 0, when it's increasing, when it's decreasing, and we can use the delta r in order to solve for these. So example 21, consider the graph of the polar function r equals f theta, where f theta equals 3 minus 3 cosine theta in the polar coordinate system. What is the average rate of change of r equals f theta over the interval from pi over 2 to pi? Okay, so this is going to be the exact same setup. Instead of doing average rate of change, or AROC, again, I want us to get comfortable with polar. We're doing delta r over delta theta. So the change in r over the change in theta. We will use f, so we'll have f of b. Our closed interval, pi over 2 is a, pi is b. So we're doing the same setup that we did in Cartesian, but it's going to have, we're going to see those thetas in there instead. Okay, so f of pi minus f of pi over 2, and then that's divided by the change in theta, which is pi minus pi over 2. So again, just like in Cartesian or Algebra 2 and earlier pre-calculus, we see that alignment here with the input and the output, those coordinates. All right, so if we plug in, I'm going to work vertically here. F of pi, we will have 3 minus 3 cosine pi, so just plug it into the expression, minus 3 minus 3 cosine pi over 2. And then in the denominator, we have pi minus pi over 2. That's essentially 1 minus 1/2, so we end up with pi over 2. Okay, so thinking about cosine of pi, that is going to be at -1. So we have 3 minus 3 times -1. And then cosine of pi over 2, that will be 0. So we're subtracting that second part, so essentially we just have 3 minus 0. And this is all over pi over 2. We end up with 3 plus 3 minus 3 over pi over 2. 2 of the 3's cancel out. So we end up with 3 over pi over 2. If we multiply with the reciprocal, we get 3 times 2 over pi, which means we're left with 6 over pi. Again, get used to exact answers, especially since we are dealing with this irrational constant pi. You don't want to go straight to the calculator, so do everything you can to simplify algebraically so that we have exact answers. So the average rate of change over the interval from pi over 2 to pi for that particular polar function is going to be 6 over pi. Okay, so now we have, it looks like, well, they give us the function. We see that vertical symmetry, so it's going to be sine. We see 4 petals, that means it's going to be 2 theta. I see a maximum radius of 3, which is here, so that means the coefficient will be 3. So I would say once you see these images, try to guess what the expression is before you look at it. That way you're able to instantly know what you're going to be working with. Okay, so 22 says the figure shows the graph of the polar function where f of theta equals 3 sine 2 theta, and we're going from 0 to 2 pi in the polar coordinate system. On which of the following intervals is the average rate of change of f of theta equal to 0? So if we want the average rate of change to be equal to 0, we are looking at delta r being equal to 0, which is f of b minus f of a. Now, it's not delta r over delta theta is equal to 0 over 0. That's, well, I don't want to use the terminology, but we can't do anything with that because we're dividing by 0. So if we want the average rate of change, as long as delta r is 0 and we have a constant in the denominator, it's always going to be 0. That's why for average rate of change, we only care about the numerator being 0. Okay. Theta won't be 0 because it's over a specific interval. It'll only be 0 if we're doing it at a single theta, which you're not going to do until next year if you're taking calculus, okay? All right, so technically we could have delta r is equal to f of b minus f of a, which is going to be 0, or we can also see it as f of a minus f of b. Order does not matter. Okay, so keeping this in mind, let's take a look at this. So over one of these intervals, the average rate of change, or delta r, should be 0. So I always say consider where it's starting and consider the orientation. Because it's sine, this one is going to be starting at the pole. We will start in quadrant 1 and we are traveling counterclockwise. Now I need you to practice remembering how it passes through the pole. It's going to have that smooth curve. The only smooth transition will be into quadrant 3. We're not going to take a sharp turn. It's not going to change directions, and it's not going to do a sharp turn in either of these. If you see it curve this direction, it's going to continue curving in that direction for the duration, especially the petals. The only time you'll see that sharp turn is with cardioids. So now from here, I'm not going to change directions. I'm going to continue. Looks like we're turning to the left, right? Turning to the left through all of these leaves. Okay, and it didn't necessarily ask for all of this, but it will help later. So we know that we are starting at the pole. So when you're trying to find average rate of change, we need to find the output values for all of these. Well, maybe not all of them, but we need to find output values for some of them so we can see what's going on. Honestly, if we look at these, we have 4 intervals, but they are using the same 4 angles. It's the family of 4s, right? So let's see what we can find out based on this. So if I want these values, let's find these two first. Let's figure out, okay, what's the r value at pi over 4 and what's the r value at 3 pi over 4, and we can figure out what is the average rate of change as we go from pi over 4 to 3 pi over 4. So let's try f of pi over 4. Plug that in, we get 3 sine of 2 times pi over 4. So that means we have 3 sine, that becomes pi over 2. Sine of pi over 2, that's going to be 1, so we have 3. So pi over 4, the radius is going to be 3. So it looks like it'll be right here. So this is pi over 4. And then if we plug in f of 3 pi over 4, why not? It's next in the family. We have 3 sine. We're going to have 2 times 3 pi over 4, so that's going to be 6 pi over 4. We'll have 3 sine. That'll reduce to 3 pi over 2. So 3 pi over 2, that's going to be here. For sine, that's going to be -1. So we have 3 times -1, which is -3. So that means at 3 pi over 4, the radius is negative 3. Now, if we follow this orientation, I hit pi over 4. My next family of 4 is reaching the maximum radius, but it's negative, which will be here. So this is theta is equal to 3 pi over 4. And I can test that. If I go negative 3, so I travel to the left, and I'm opening up 3 pi over 4, orientation is counterclockwise, I end up at that same exact coordinate point, okay? So yes, that's theta 3 pi over 4, even though on our unit circle it's here, but that's the point of polar functions, is that they bend and twist in ways depending on the attributes of that polar function. All right, so let's take a look at this. So if we know that the average rate of change will be delta R is equal to f of b minus f of a. So now we have f of a, well, we can call this f of a, we can call this f of b, but we want to find the change in these, so we will take the difference of the two. So for a, delta R, f of pi over 4 is 3, and then we will subtract f of 3 pi over 4, which is negative 3, but I get positive 6. Therefore, the answer is not A, because that's not 0. So let's try B. Luckily for B, we just have to find pi over 4. We already found 3 pi over 4, so let's do f of 5 pi over 4. Now, if you understand the orientation of this, if we were to follow this, because now my next angle will be 5 pi over 4, it's going to be here. All right, if I'm following the orientation of the polar function, this should be theta equals 5 pi over 4. And if we think about the unit circle, that is where 5 pi over 4 is. But also I can test it by plotting the coordinate. I'm assuming that this is 3 5 pi over 4. So I'll go out a radius of 3, and then I will travel counterclockwise 5 pi over 4, and I end up there. Okay, so that's proving it graphically. If you understand your orientation, you can already see that this is going to be positive 3. However, if you need that justification for yourself, go ahead and plug it in. So I have 3 sine of 2 times 5 pi over 4, which is 10 pi over 4, which means that will simplify to 3 sine, whoops, I kind of messed that up a little bit. That should be 10 pi in here. So that means we get 5 pi over 2. I'm going crazy. Hold on. So we have 10 pi over 4, which reduces to 5 pi over 2. Oh, we're going to have to find a coterminal. 5 pi over 2, if I subtract 4 pi over 2, because that's 2 pi, I end up with pi over 2. So that means we have 3 times 1, which is equal to 3. All right, so that's justification that this is going to be pi over 4 here. 5 pi over 4, sorry. So now I know that, let's check the change in the average rate of change. We want it to equal 0. F of 3 pi over 4 is negative 3. And then I'm going to subtract f of 5 pi over 4, which is positive 3. We get negative 6, which is not 0. Nope, not that one either. I also want to call out, make sure you're not trying to, average rate of change means, well, average rate of change of 0 means a horizontal line. In Cartesian, it does. But in this one, in the coordinate system, we're bending, okay? So that horizontal line isn't going to help you in this coordinate system. So don't rely on that. So don't go, it's pi over 4 to 3 pi over 4. Well, first off, 3 pi over 4 is over here because the radius is negative for that coordinate. So you're already selecting the wrong choice. All right, so don't go back to Cartesian. Like, this is not a vertical tangent, or this is not a horizontal where the average rate of change is 0. You have to let go of all of that since we're in a completely different system. Okay, now we have 3 pi over 4 to 7 pi over 4. We know f of 3 pi over 4, but let's find f of 7 pi over 4. Again, there is a pattern. I see positive 3 for pi over 4, negative 3 for 3 pi over 4. I see positive 3 for 5 pi over 4. Well, after we travel through 5 pi over 4, I'm going to quadrant 2. This is opposite of where 7 pi over 4 usually is. All right, so that means the radius will be negative for this one as well. So it will be negative 3. If you want to check it algebraically, you can, and you should get negative 3. Okay, so for C, I want to find the average rate of change. F of 3 pi over 4 is negative 3, and we're going to subtract f of 7 pi over 4, which is negative 3. So we get negative 3 plus 3, which is equal to 0. There it is. So I'm using delta R to find the average rate of change within these intervals in order to see is it equal to 0? And we want to see that delta r, or the change in r, is equal to 0. So 3 pi over 4 to 7 pi over 4, this is where the average rate of change is equal to 0. All right, number 23. It says, in the polar coordinate system, the graph of the polar function is shown with the domain of all reals from 0 to 2 pi. On the interval of theta, the graph has no holes, passes through each point exactly one time, and as theta increases, the graph passes through the labeled points A, B, C, D. All right, so we have A here, and then it passes through B, C, D. And these are in order based on the orientation of this cardioid. So we're traveling counterclockwise. Now for this one, they don't give us a polar function, right? They just say, oh, here it is. And you don't have to remember the attributes of a cardioid. We can use information from the graph in order to figure this out. So on which of the following intervals is the average rate of change of r with respect to theta the least? So when it says the least, we are still looking at delta r. And we want to find when delta r is the smallest. Well, not necessarily the smallest, we'll say is the most negative. Is the most negative. Because if we say smallest, that means closer to 0. But we could get a negative average rate of change, which would technically be the least. So we're going to use delta r to find which interval the average rate of change of r with respect to theta is the least. So let's look at A. Option A. We're going from A to B, so that means delta r is equal to, you can use A minus B, well, yeah, let's do B minus A. So we'll do f of B minus f of A. So we'll do the end of the interval minus the beginning of the interval. Up in, sorry, my phone just fell. Up in example 22, it didn't matter which one was first because we wanted 0. But for A, because we want the least, we want an actual value, let's do the end of the interval minus the beginning of the interval. So B minus A. So if we zoom into this graph, let's determine what r is equal to. Let's do that in pink here. So A, B, C, D. If I look at A here, my A, I travel out in the positive direction, and I have a radius of, it looks like about 3. It's like in between 2 and 4. So I'm going to say, okay, A is about, it has a radius of about 3. And then as I travel around, I come back to the pole, and then I'm opening up to my next coordinate, which is B, okay? B is the same. It has about a radius of 3. Now, I know it's not negative 3 because I'm not crossing the pole. So remember, you'll get that negative radius when the polar function crosses the pole. It comes back to the pole, but it doesn't cross it to create that negative radius, because that's what the inner loop, negative radius. When it crosses with the leaves and the petals, negative radius. But with the cardioid, it just touches it and then it continues on. All right, so we'll say about positive 3. And then going to point C, we're sweeping around. If I look at this, so I see 2, 4, 6. It's about between 4 and 6. So I'm going to say that it has a radius of about 5. Let's do that. And then as I continue around to D, I'm going to say the same thing for D. It has that symmetry with C, that it has a radius of about 5. And then we come back to the start where we were. Okay, so if I'm looking at A is B minus A. So that means I'm going to have 3 minus 3. I'm pulling it from here. The coordinate point A has a radius of 3. Coordinate point B has a radius of 3. So we'll do 3 minus 3, which is 0. So now let's try B. The change in the radius for B, so we'll do C minus B. I'm taking, it's going from B to C, so I'll do C minus B. The radius at C is about 5. The radius at B is about 3, so we'll get 2. So right now, our true candidate for where the average rate of change is the least is A, because 0 is less than 2. So I'm just going to go ahead and scratch out B. All right, let's try C. So from C to D, so delta R is equal to D minus C. D, we have a radius of about 5. And then at C, we have a radius of about 5. 5 minus 5, that's 0. So now these are the same. So fingers crossed that D has a different value, hopefully less than 2. All right, so the change in the radius from A to D, so we'll do, sorry, D to A, so we'll do A minus D. A has a radius of about 3. D has a radius of about 5, so we end up with -2. Okay, good. So that gets rid of this, that's the tie. We can get rid of that tie. That means the answer is D. So traveling along this polar curve, the average rate of change from A to B is going to be 0, because we can see that the radius is 3 on both sides. From B to C, the radius is increasing because we can see that it's extending out further as we travel to C. From C to D, it's going to be 0 because they both have a radius of 5. And then going from D back to A, we can see that it's shrinking here. It's getting smaller. Therefore, the average rate of change for the radius is going to decrease. All right, so this next one, you have a couple more problems. So this is estimating values of R using the average rate of change. So what we did up here, we're going to, add in example 21, we're going to use for this part. So for a given interval, we can use the average rate of change over the interval to estimate other values of R inside the given interval. Therefore, we have this thing. Okay, hopefully looking at this, again, I'm trying to stay away from Cartesian, but there are some things that overlap. Think of your point slope formula. You're like, oh no, what is that? I haven't seen that in so long. Well, point slope is going to be y minus y sub 1 is equal to m times x minus x sub 1, okay? This is essentially the point slope formula, but in polar coordinates, in the polar coordinate system, okay? So your y, that's going to be your f of theta. That is your output. F theta sub 1, that is the y sub 1. And then plus that f of b minus f of a over b minus a, that is just your slope, okay? That is our delta r over delta theta, okay? And then we have x minus x sub 1. So we're looking at the point slope formula, but it's in the polar coordinate system. However, I do not believe it is called that because we use it differently. Well, I don't know if they call it that. I should probably look that up and probably should have given that information before I recorded this video. But just knowing Cartesian is the point slope formula, I don't think it's called that in polar, but I'll find out for you, okay? So again, if you're asked to use the average rate of change to find or to estimate, you will use your point slope formula. So where f of theta sub 1 is a known point on the graph, so that theta sub 1 is the known angle and the known output for that angle, okay? And we use that angle in order to estimate another output that's close to it. So the average rate of change of R with respect to theta over the interval from A to B is given by f of b minus f of a over b minus a, and that is our change in R divided by change in theta. Okay. Let's see. All right, they haven't asked us to do anything just yet, but we do need to find delta R over delta theta before we do example 24, okay? So our known point, we have two known points. So, okay, let's just do 24. I think it's all going to connect anyway. So the table above gives values of the polar function R equals f theta at select values of theta. Use the average rate of change of R over the interval from pi over 6 to 7 pi over 6 to approximate 5 pi over 6. So the first thing that we need to do with this is that we're given this interval, pi over 6 is your A, 7 pi over 6 is your B. That's the start to finish for this interval, okay? So to find the average rate of change, we'll have delta R over delta theta is equal to f of 7 pi over 6 minus f of pi over 6 divided by 7 pi over 6 minus pi over 6. F of 7 pi over 6 is going to be -1. F of pi over 6 is 2. 7 pi over 6 minus pi over 6, that's going to give us 6 pi over 6. So we have -3 in the numerator, and then we end up with pi. So this is essentially our slope. That's our slope, or your m, for your point slope formula, okay? So now we have a couple substitutions. We have theta sub 1, we have f of theta sub 1, and we want to solve for f of theta. This is what we're looking for. So remember, the theta sub 1 and f of theta sub 1, that is your given, okay? That is going to be your given. Okay, so which one do we want to use if we're at 5 pi over 6? Usually we want to use the point that is the closest. That will give us a better approximation. But I'm going to use, because let's see, pi over 6 is here, 7 pi over 6 is here. We want to find the average value for 5 pi over 6. Okay, in the notes, I used pi over 6, but I'm going to use 7 pi over 6 for this one because it's closer. So let's see what happens. So the theta that we are solving for is 5 pi over 6, which means theta sub 1 will be 7 pi over 6, and then f of theta sub 1 is -1. Okay, so again, in the notes key that I posted, the PDF file, I used pi over 6, but 7 pi over 6 is closer to 5 pi over 6, so I'm going to use that one and see what happens. All right, so f of 5 pi over 6, if we think of our point slope formula, we're going to do minus f of 7 pi over 6, which is equal to delta r over delta theta times the theta we are solving for is 5 pi over 6, and we are using 7 pi over 6. All right, so this is what we're looking for. So again, this is our y minus y1 is equal to m times x minus x1. So f of 5 pi over 6, that's what we're looking for, minus f of 7 pi over 6 is equal to -1. Delta r over delta theta is -3 over pi. And then 5 pi over 6 minus 7 pi over 6, that gives us -2 pi over 6. There's a bunch of negatives. Maybe that's why I used the other one. Okay, so we have f of 5 pi over 6. We have our plus 1 is equal to, we end up with 6 pi over 6 pi. Oh, wow. So now f of 5 pi over 6, if I subtract that 1, this just becomes 1. So I get 1 minus 1. Therefore, f of 5 pi over 6 is equal to 0. So I actually got the same answer as when I did in the notes key from here. So this is pretty extravagant that it's that accurate. Okay, the last is solving systems, but I will be in class on Monday to go through that with you. It'll be kind of quick. It might take half the class, but that way I can take questions from you. All right, hope this helps.